Hello guys and girls, and welcome back to my YouTube channel. And today I'm going to be teaching you guys how to use how to solve homework linked lists. So first of all, let's go over the code where we're going to be needing. So we need a class node on each and every single one of them. So let me start opening these up. And so class node, you're obviously going to put the same thing here. Just
Are you sharing your screen or no?
Oh, am I not sharing my screen? Oh, I'm sorry about that. Let's see here. Screen 1. Are you guys able to see my screen?
Yep.
Alright, so first things first, a class node. We're going to be discussing that. Do I have that in my priority queue? I see. So let's do that. First is our constructor of class node. I think he has gone over this in class with you guys, has he?
No, I don't think so.
Oh. So class node, it's a very simple class that you're going to be making. It's just connects 2 points. This is a node. And this over here, it's next. So, what we're going to have in class node is this thing called next. It points to the next process. So, you can just call this node next. It's a pointer to a node. Like that. And then, what type of information will this have? Let's see here. It's gonna... must be templated. What is this one gonna do? So this is an integer data. As you can see here, it's pushing integer values. So what is this one? This one's StackLL. So we're gonna have some, I don't know, some data here. Data. You guys, okay, so you have this. This is your next. And right here it's data. What it contains, the information this contains. And this could be anything. It can be string, a character. When you're working with nodes, it can be anything. But in this case, what we're doing is we're using an integer value, so that's why it's going to be int. And then we're going to have a constructor, a node, and we're going to initialize this to null pointer because it means that there's no neighbor. And we're going to initialize data to whatever, like, I don't know, you can put -1, 0, doesn't matter, as long as like it's not an actual value that you're going to be using. It could be 0, to be honest. And then we're going to have our constructor with parameters. I don't know if you guys know. So there's an initializer, and we're gonna have another initializer with parameters, and we're just gonna pass in the data. So how do you do this? Is that we want data to be something. Int of e, and then right here you just do data is equal to e, or you can do this. There's a this keyword, that meaning that you're working in this node, and then you do the same thing as here where you set it up as null pointer. So right here it's just going to be null pointer here and then null pointer there. When you're actually working with linked lists, you're going to be assigning them to another linked list. So how this would work in code is, I don't know, let's call this node head, and then head goes to next, and next is equal to new node. So this is how you would create a list. Because there's our head or something like that. and this is going to be our new node that we're adding, and we're connecting it through our next command. All right, does that make sense?
Yeah.
All right, that's good to hear. Now,
Wait.
huh?
So what do we set to no pointer again?
You're gonna your next your node is gonna be set to no pointer. So the main reason we do this is so we check that we're ending at this point.
All right.
So for example, this one has right now a null pointer. So as we're iterating through our linked list, let's go. I'm here, and then I go here, and I want to go further beyond, but I can't. Main reason is because null pointer's there. I'm checking like, hey, if this is null pointer, stop, because there's no other elements. You're not gonna do another next. You can't do it because there's nothing to go to. All right, that makes sense, man. Bunch of students today. Man, I really love it when there's a bunch of students here. Now, let's get into one of them. So let's go into StackLL. Stack. So StackLL, the constructor, is just going to be making one of your first initial node. So you either have a top, because it's stack, or you can call it whatever. Doesn't really matter as long as you know what's your first variable, your first node is. So we're gonna set this to null pointer because, well, it has no neighbors. It itself has nothing. And then what I do for the deconstructor is I iterate through the linked list and delete a node. So it's deleting every node at n variables. It takes care of the memory leaks, so you can just iterate through it. I'm not sure if I'm allowed to teach you how to iterate through a node, but it's mostly just you just loop through it. You can use a while because you know the condition. If this is here, if it's null pointer, then if it's not null pointer, sorry. So if it's not equal to this, you just go next. You just move to the next one. You're gonna have like some node here, a temporary node. You can call it temp or something T, and that's what you're gonna be using for your next. So you can just change this to temp. And that's mostly it for the deconstructor. Well, you're gonna be iterating through the nodes on the deconstructor. And there's going to be a keyword called delete. And you can delete the node you want to delete at that point. So you would do delete temp. Yeah. That would mostly be it. Empty. If it checks if it's empty. So for stack LL, the empty, it just mostly checks if your head or your top is null pointer. So you just return that. There's not much to it without giving you actual code, so I'm not gonna do that. So you guys can figure it out. The push one. All right, now this one I'm actually going to draw out for you guys. It's fairly simple. So how push works in linked lists is that you have your initial node. Let's call this head. And let's say, let's add a new. Well, we can. Let's say this one has 0, and we want to do a push. So we add a new node. So let's say we create a new node, and let's do this. Let's call this new node. Where it has a value of 15. So what we would do is we put it here, and then this is going to be our next, remember? And then we plug it in here. And that's basically it. You use your next on the new node. Because we know that next is a pointer to a node. So, new node could be this. Yeah. This is not correct, by the way, but it's to let you visualize what next could be assigned to. It could be assigned to a node. So you can do next, new node. You can use a new keyword and then new node. Oh my god! But you get the gist of it. All right. So there's this one called pop. Do you guys get what I mean on this one?
This is the push function, right? We're working on right now.
Yeah.
Okay.
So does it make sense? Does anyone need me to clarify anything? All right, that makes great to hear. Great to hear. Great comments here.
It seems pretty straightforward.
Huh?
It seems pretty straightforward, right?
Yeah, it's pretty straightforward. It's one of the easiest homeworks Dr. Schroeder gives out.
I was talking about the push function, but okay.
Oh. Yeah. The pop one, fairly simple. Just remove the top item. No iteration is going to be happening here, so the cost of it is worst case. Remove and return top items from stack. So how this one will work is that you're going to be controlling your top. And you're just going to assign it to the next node. But keep the value of top, by the way, just because you're going to be returning that value, returning the number. You're going to be returning the value. So this is what you would mostly just do to get rid of that node from your top. Because you guys know how stacks work, right? It goes from top to bottom. Kind of like a queue system. So let me illustrate this. So let's say I have this item. Let's say this one has one item, or a value of 1. Let's call this our top. And let's say I want to remove this item. Well, what we just do is just grab this and set it equal to the next and just place it there. And then this chain cuts off. And then what you can do is you can assign this as a temp variable and just grab the data from it. So temp data, you can return this. Yeah, does this one say anything about memory leaks? Not really. So you can either do this, or you can assign it to another element, an int value, and delete it for memory leaks, and then return that int value. int variable you got. That's mostly it. It's like, I mean, it's not rocket science. So, does that make sense on that one? Do you guys need me to further explain? All right, good to hear.
Do we need to reassign top to the variable before it was deleted, or to the pointer before?
Yeah. Yeah, that's what. So, right here's top, and just we reassign it to the next value. So yeah, you're right. You reassign it. That's what I meant from this. Like, oh, you just grab the top here, just reassign it over here. That's mostly it. But keep in track of what this is, because you need that data to return. So you can do it different ways. Yeah. Now we're getting into the InsertAt. So, InsertAt, that one's a pretty fun one. I'm gonna illustrate it to you guys. So, some conditions we need to check is that if our first InsertAt is at 0, where would you input this node? Let's say there's our linked list. Yep, we would insert it to the top. So let me just do this. Null pointer. Let's do that, and then let me create a new node. This is the new node, and let's do a little arrow. So let's say I want to insert it at 0. Well, I just grab this and do this. This turns position 1. This turns into position 2. How do you do this? Is just assign the next value to your top, and then so you know the information doesn't clear. You just assign this node, because this node contains all of this information, back again to the top. It's a little bit wordy, but what I mean is that okay, let me tell you guys what I mean. So right now, this is top, and top only contains these nodes. I add this new node, and I connect it to top. Now, new node contains all of these nodes, but we want this information to be capped. So what we would do is we would reassign top to new node. So does that make sense? You're just reassign it. Alright, that's the first condition. Like if they give you to insert at 0. Now the second one is your insert at any point. So let me just illustrate to you guys what I mean. I hope Dr. Schroeder likes these videos. I hope he watches them in his free time. Maybe he hears the podcast when he's working out. Maybe. Just think like, man, I have the best TA. So, this is what you're going to do. So what we know is that this node is 0, 1, 2. Lo que sea, ma. 0, 1, 2, and we're going to be connecting it. So right now, it looks like this. 0, 1. But what we want is to connect this at index 1. Now, what we need to do is just, pretty straightforward. You just reassign this next to this new node. So let's call this new, because I'm tired of writing new node. Or let's just call it N for node. And let's call this T for top. So we just reassign T's next to node. And then just reassign the new nodes next to this point. And this becomes your index 2, index 3. And then you start recursing through just so you can keep the information. You don't have to reassign it because top is the one. Top is keeping track of every node. So does that make sense on the thing? Straightforward. You guys are not gonna message me tomorrow asking for help. Good to hear. Good to hear. So you guys understand the concept that you're just gonna be chaining this next to the new node, and the new node's next to the previous node you had from the top. So what I recommend here is that you just hold this value before you start chaining. Let me see. At next equals. Yeah, that makes sense. Yeah, I'm good at programming. Yeah. Alright, that makes sense to everyone. No one has trouble with it. I don't know what you guys expect from me. Do you guys want the answers or something? Now, let's get into the queues. So, same process. There's a queue. Linked lists. Same process for the nodes, the node class, the constructor, the deconstructor, the Enqueuee. That one's fairly simple because you're just iterating through the linked list. So, does anyone have an idea on how to make this one? You want to give me some tips on how to do it? Or Enqueuee. So this one, just iterate through. Just iterate through it all the way to the end. And once you hit null pointer, that's where you add the variable. So once you hit null pointer, that next, that temp, that is null pointer, or I'm not gonna write next because that's gonna confuse you. Next is gonna be equal to null pointer. You just reassign it to that your new node. So next is gonna be your new. And that's mostly just it for it. You iterate through your linked list. If it's null point, once it hits null pointer, you just assign that value to your next. Because how Enqueuee works, let me see if I can give you guys a visual explanation on this. Let me see. Because I have my own PowerPoints that I totally didn't steal from another professor. Which he does not work for this college, I believe, anymore. Data structures, graph, linked list. Is this stacks? Which one's this one? Stacks and queues. So,
Oi.
oh god, I don't know why it's like that. No way. Give me an actual proper. So let's go through here. I'm not doing this now.
It's near the end of the PowerPoint.
Yeah. So yeah, you see how it's it pushes from the top, and then keeps going. So top is gonna be, and when we're popping it, we're gonna pop from the top, and boom, you just remove it. So that's how it works. You push, top, you push again. There's gonna be your location, and then when you pop, you pop the biggest one. Is that what I explained? Did I explain that? Yeah. I did explain it right. Yeah. So then, wait. Don't look at that code. Ah, wait.
Skip most of it. The queue doesn't have much code.
Yeah, the queue does not have much code. Does he have an illustration how that works? Yeah, there it is.
I think it was mostly words.
Yeah. So there's your enqueue. You go to front. You put it. Your front, and then your next variable, your next node, and then there's the rear. So this rear is going to be null pointer, and then when we pop in the beginning. So I'm going to show you guys how to do the first enqueue. So there's your head, and then we just pop a new item to our next. So we're iterating through until we find null pointer. And let's say we just found it. And once we find null pointer, let's get this guy's thing. Let's call this, I don't know, this head or something again. Or no. Let's call this. Let's just do this. Yeah, this is what you're gonna do. Just that. Just assign this next to this thing, and that's it. That's fairly simple. Now, Dequeue, fairly simple as well. You kind of just did it in the other one. Let me see here. Yeah, you kind of just did it in the other one as well, so the pop will be the same thing as your Dequeue. Does that make sense? Like, it's kind of similar process at this point. Now let's get into decrement. Now this one's pretty fun. So what you can do here is you're gonna be you're gonna iterate through the temp or through your linked list, and okay, let me illustrate how this will work. So decrement, I'm just gonna do something similar to it. I'm not gonna write three nodes. So this is decrement, and I'm gonna, well, not decrement, but I'm gonna remove every single 2 items. So I iterate through my list. I check. Okay, this is 0. This is I don't know. Every 2 items. So this is my first item I see. Ah, this is the second one. Let me delete this. Ah, you don't exist anymore. You're canceled. You're deleted. Now what we do here is we're gonna keep track of our previous information and just connect our next, the previous next to our new next. Oh my god, this is a wordplay. But let's see here. Delete the
What
10.
is this? Thank you.
No, this is decrement. Why did I skip forward? No, this is decrement. Decement. Oh my god, it's dissonant. But I'm just doing only just two variable, not Dequeue. So we just, I don't know, delete this node, connect it from get our previous node, and then connect it to our next node from the one that we deleted. And then we would reset our counter. Let's say this one again.
I think he means decimate. Oh.
My god, I'm bad at it. This is why I'm not an English major.
No, that's okay.
Lo que se llama.
Because no one's saying.
So 1 and 2. And then we do the exact same thing. We get this, we delete it, and we see that there's no other information.
Wait, that question. So is decimate basically the opposite of the InsertAt?
Yeah.
Oh, okay.
But you're gonna keep track of every 10th value, and you're just gonna delete. So how would you implement this? Just iterate through the list. Just go through the list until you hit null pointer. Every 10th value, every 10th node you have, you just store the information. So I have two things. I have two nodes. One being my previous node. So this previous node is going to be this. And then my current node is going to be this. And then the next one. Next. This is the next, by the way. So you don't have to worry about it much. But we're gonna keep this previous node just to keep track of like just to keep track of this, just to connect it. Because once we delete it, we have to reconnect it, rechain it, just to our current next. Does that make sense? Is there like something unclear? It doesn't make sense or anything?
Yeah.
Yeah. So you iterate through it. You have a counter. Keep track of your previous. And if you land on that 10th node, you're gonna chain your previous node to your current next node. And then you would delete the current node you're at. And then you would reset it by saying, you would reset this information by making current, because you already deleted this node, you deleted it, now you set current is equal to your previous. And this is where it gets a little bit messy for me, because I added this current and previous, so it's gonna recount this one, and you're gonna have to go, so it's gonna recount this one again. So what you can do is set your counter to -1, just so it doesn't count this one, but it continues on going forward. And then from right here, it starts back at 1, and then the next node's 2, 3, 4, blah blah. You get it, right? Is there anything unclear here? That's great to hear. Am I recording? Yeah, I'm recording, so I'm gonna have to explain this later. I'm gonna send you guys to this. Now this one. Now the next one, priority queue, you're gonna be using templated. So you guys know how to use templates? It's just at the very top you just do a class T. And just use it's a template. A template basically means that it can contain any sort of information. So it can contain an integer value, a string, it can contain I don't know, a class. Yeah, anything. That's a templated variable. Now, same process as before. You have your node constructor, your class, same process. You set your constructor head equals null. You're a destructor, same process as well. You're empty, same process. Now the inserts. Now, yeah, Carlos, you forgot the awesome TA's question. You forgot that part in your sentence, Carlos. You might want to edit it as I'm viewing here. So insert, fairly simple. You guys know how priority queues work, right? So priority queues work basically like this. I'm just gonna draw it out without having the list. So for this one, you can go from the top to bottom. I don't really. There's no correct solution of where you go, but let's say I do my. Okay. Let me rephrase this. You can order this from top to bottom, or bottom to, from biggest value to lowest value, or to lowest value to biggest value. Doesn't really matter. But all we want is to have an order in which we're going to be extracting the minimum number. So we would start comparing. So this is my element 1, 2, and 3, 4. And let me change this up. Let's do this. Let's do this 40. This is 20. This is 25. And I want to add this new node that's 10. How we would do this is, it's going to be a similar process to InsertAt, but what you're going to be doing is just iterate through this whole list and compare the items. Like, hey, is this less than this 10? Ah, yes it is. So I keep going to the next value. Hey, is this 10 less than 20? Wait, am I doing my calculations right? Yeah. Let me rephrase it again. So we want to check from between these two which one's the bigger value, or smallest, depending on how you have your order. Right here, we're checking which one's the bigger one. So this 10 is bigger than 1. And we already know that 1 is the minimum number. So we go on to the next one. Is this 10 bigger than 20? No, it's not. So what will you do here is you unchain it. You unchange the next here. So store this information. Store this one. Because let's say that it's going to be our temp next. And it's just going to contain all of this linked list. And then we're going to reassign this next to this guy. And this guy to this guy. So this node's next. There's our previous node. There's the next variable. And there's our current. Remove data type. Yeah, I already got. I told you guys how to do this, right? Yeah. So that template cut and equal sign and equal sign. Wait. Yeah, this is how you. Similar. I'm using reply. I'm not sure. I mean, for this homework, I don't recommend Replit. Main reason is because of memory allocation. It can cause several errors, and it's not very good when it's explaining to you where you're doing errors, like where you're filling. Also, you're gonna be using breakpoint. Let me type this to you guys, but it's so because I don't know if you guys ever read the documentation for it, but like you can just write it out. Let's go here. Okay. C++. You can just go for the documentation. Remember, well, there's not the actual documentation. This one either. This one, yeah, this one is. That tells you right there how to use template cows. Let me just give you guys this. This should work. So you guys know how to do this, right? Do you guys understand the example? Man, great crowd here today. Totally makes me feel like YouTube. I mean, putting this. And then the previous extract minimum. We've done this before, so let me just do that real quick. Let me just reassign this. Blah blah blah. Depending on where you have it, let's say. All right, I'm gonna do 2 examples. I did template int. Is that not? No. Read the link. Read the link, guys. No. Read the link I sent. So, from here, do you guys know what you're gonna do? How you're gonna do it? We've done this previously, where we're doing Dequeue. So this is your top or your head. Let's see, there's your head. And there's your tail, I believe. I'm not gonna. There's the end of your loop, your thing. So for this one, if you're doing this method, wait, Frankie, are you here? No, Frankie's not here. You just, I mean, I don't know how to explain this because this one's pretty simple, but you just move your element to the next one, delete that. So it's similar to what we did in Dequeue. It's a similar process. In this one, you just unchange the information. So this one, similar process as Dequeue, depending on how you have it set up. So we just make our head into our next. That's it. Just set it to next. Nothing major here. Fairly simple. This one, fairly simple too. We iterate through the list. And once we hit null pointer, keep track of like now that we hit, wait, keep track of your previous keep track of it. So this is going to be your previous and current. This is going to be your current. And once current gives out a null pointer, you're going to previous and setting this. You're setting this previous to null pointer. And then you're deleting this guy. Yeah, you just delete him. And then you reassign your things. You reassign your head to previous, or not previous, not previous. You just, how could I say this? Because this method, you have to iterate through it, keep track of the information, and set previous to current. You're still manipulating, so you're just gonna make your previous into a null pointer, keep everything in track. So I don't know how to explain this, because I didn't do this method. I did the other one where I'm doing the head. But this should work similarly. Just keep track of your previous, your current, and I believe that should be it for this homework. There's nothing majorly big. Does that make did this last one make sense on the extract min? All right, good questions here. Any guys? I don't bite, guys. Like I'm here to help you. Just tell me something. Human communication is pretty important. Alright, is that alright? I'm just gonna stop recording at this point. Yeah.